Hello children, hope you performed well in your PT-1 examination. So today I am going to discuss questions asked in PT-1 examination. So let us start learning questions and to react according to the responses you made in your exam, and you can also rectify your mistakes if you did any in the examinations. So let us start with question number 1. The minimum charge on an object is minimum charge. Can you recall quantization of charge? Yes, you can recall quantization of charge, that Q is equal to NE. What will be the minimum value of N? Minimum value of N is 1. Okay? Or minus 1. So what will be the minimum charge on a body? It is equal to plus E or minus E, small e. And you know the value of E is 1.6 into 10 power minus 19 coulomb. That is charge on an electron. So what will be the minimum charge? 1.6 into 10 power minus 19 coulomb. You have 4 options. Option A, 1 coulomb. Option B, 1 stat coulomb. You know stat coulomb is the CGS unit of charge. Option C, 1.6 into 10 power minus 19 coulomb. And option D, 3.2 into 10 power minus 19 coulomb. So what will be the answer? Answer will be C. Hope you wrote this C as the answer. Question number 2. A charge Q1 exerts some force on a second charge Q2. If third charge Q3 is brought near, the force of Q1 exerted on Q2. Can you recall principle of superposition, in which I discussed that if you are talking about the force between two charges, presence of third charge will not affect them. Okay? But if you want to find the net charge on a force, then all the charges surrounding the given charge will be taken into consideration. So here we are talking about the force between two charges Q1 and Q2. And force between Q1 and Q2 will be independent of the presence of the third charge around it. So whether Q3, Q4, Q5, Q1 will come there, the force between Q1 and Q2 will not change. So what will be the answer? Answer will be remains unchanged, which is option C. Got it? Now question number 3. A soap bubble is given a negative charge, then its radius. A soap bubble is given a negative charge. How does we assign negative charge? You know, when electrons are transferred to a body, then the body acquires negative charge. And you know, whenever electrons will increase, the size will increase. Okay? And if size will increase, what does it mean? It means radius will increase. So option A is decreases, option B is increases, option C remains unchanged, option D increase. No, option D, nothing can be predicted as information is insufficient. What will be the answer? Answer will be increases, means the radius of soap bubble will increase. Got it? Okay. Question number 4. Plus 2 coulomb and plus 6 coulomb. Two charges are repelling each other with a force of 12 Newton. Suppose there are two charges plus 2 coulomb. Suppose here is a charge plus 2 coulomb and here is another charge plus 6 coulomb. As both the charges are positive, so they must be repelling each other. They repel each other. Okay? Now, if each charge is given minus 2 coulomb of charge then the value of the force will be, you see, if you will put minus 2 coulomb charge here, what will be the net charge here? It will be plus 4 coulomb. And if you will put minus 2 coulomb here, what will be the net charge here? It will be 0 coulomb. So what will be the force between two? 0 coulomb and plus 4 coulomb. Obviously it will be 0, because you know F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. If either of Q1 and Q2 will become 0, the force will become 0. Here you see one of the charges becomes 0. One of the charges becomes 0. So the force will become 0. So what will be the answer? Answer will be 0. That is D. Got it? Now question number 5. Equal charges Q are placed at the four corners A, B, C, D of a square of length A. The magnitude of the force on the charge at B will be. You see, this is a square. Question number 5. This is a square. Okay. Here is a charge Q, charge Q, charge Q, charge Q, side A. Now you have to find the force on the charge at B. Force on the charge at B. You see, force on the charge Q at B due to A will be in this direction. So this is FBA. Got it? Force on charge Q at B due to this charge Q at C will be repelling, means FBC. Got it? You see, both of these will be equal in magnitude. So their resultant will be along this direction. And force on charge at B due to this charge at D will be along this direction. This is FBD. Got it? So can you find the value of force FBA, FBC and FBD? Yes, obviously you can find. You see, FBA is equal to FBD. They are equal in magnitude. Okay? So 1 by 4 pi epsilon naught Q1 Q2. You see, QQ means Q square by A square. F, this is BC, BD no, BC, FBA and FBC are equal. FBD, it is equal to 1 by 4 pi epsilon naught. Again Q1 Q2 are equal, means Q, so this is Q square. By this distance, you see, this is the diagonal of the square, and diagonal of a square is root 2a, means this is root 2a. So square of root 2a will be 2a square. Got it? And resultant of these two forces will be along this force. So at first we find the resultant of these two, means FBA plus FBC. Its resultant is equal to, you know, when two forces are equal in magnitude, their resultant is 2 into either of the force. 1 by 4 pi epsilon naught Q square by A square. Cos theta by 2. You see, cos theta, this is theta. This is how much? 90 degree. 90 degree by 2 is 45 degree. And cos 45 degree is how much? It is 1 by root 2. So it is 1 by root 2. You see, this root 2 will cancel this 2, root 2 times. And this is along this direction. So what will be the net force? Therefore FBA plus FBC plus FBD, all are in the same direction. So 1 by 4 pi epsilon naught Q square by A square can be taken as common, and it will be 1 plus root 2. 1 by 4 pi epsilon naught Q square by A square. You check the option. You see, 1 plus root 2, 1 by 4 pi epsilon naught q square by a square. Okay, so FBA plus FBC, this is 2 into either of the force 1 by 4 pi epsilon naught q square by a square cos 90 degree by 2 means cos 45 degree, and cos 45 degree is 1 by root 2. You see this root 2 will cancel this 2 root 2 times. So root 2 into 1 by 4 pi epsilon naught q square by a square. You understand that the direction of this force FBA plus FBC will be along the bisector of this angle 90 degree. So it will also be along the diagonal. Okay, and this force is along the diagonal. So both of these are in the same direction, hence the resultant of these three forces FBA plus FBC plus FBD magnitude is equal to sum of these two magnitudes, that is root 2 plus 1 by 2 1 by 4 pi epsilon naught q square by a square. LCM will be 2 root 2 plus 1 1 by 4 pi epsilon naught q square by a square. Got it? So what will be its answer? Its answer will be C. Okay. Now question number 6. The potential at a distance r by 2 from the center of a conducting sphere of radius r will be. Okay. So you know in a conductor the total charge resides on its surface. Electric field inside a conducting sphere is 0, but electric potential inside a conducting sphere remains same throughout from the center to the surface, and it is equal to the potential at the surface. So potential at the surface is 1 by 4 pi epsilon naught q by r. What will be the answer then? Answer will be C. Now question number 7. Equipotential surfaces associated with an electric field which is increasing in magnitude along the x direction. Magnitude along the x direction are, option will be A, planes parallel to yz plane, as it is electric field is increasing along x direction, and you know electric field is perpendicular to the equipotential surface. Electric field is along x direction, and the plane perpendicular to x direction will lie in which plane? In yz plane. So answer will be A, planes parallel to yz plane. Now question number 8. A charged ball B hangs from a silk thread S. This question will be solved numerically. This is having a diagram, a charged ball B. So let us draw the diagram first. You see question number 8. This is the diagram. Positive charge seat, and this is the ball B, sphere S. A charged ball B hangs from a silk thread S. S represents the silk thread, which makes an angle theta with a large charged conducting sheet P. You see, this is the angle theta as shown in the figure. The surface charge density sigma of the sheet is proportional to the surface charge density. Here you see surface charge density is sigma. If the mass of the ball B is m, here will be its weight mg, and electric field is away from the charge sheet. You see this is which makes an angle theta with a charge sheet. Okay, so this electric field is sigma by 2 epsilon naught. You already learnt it in the application of Gauss law. If charge on the ball is Q, suppose the charge on the ball is Q, so what will be the force on the ball? Q into E, means Q into this E. This is the tension in the thread T. This T will have two components, one along this. This is T cos theta because this is theta, alternate angle, and this is T sin theta. T sin theta. You see the ball will be in equilibrium if T cos theta is equal to mg and T sin theta is equal to q sigma by 2 epsilon naught. Only then the ball will be in equilibrium. So T sin theta is equal to q sigma by 2 epsilon naught and T cos theta is equal to mg. You divide this equation by this equation, you see T will be cancelled out and sin theta by cos theta is tan theta. So tan theta is equal to q sigma by mg into 2 epsilon naught. So from here you can have sigma is equal to mg 2 epsilon naught by q tan theta. Got it? Here you see mg is constant for the given ball because mass of the ball is constant. 2 epsilon naught is already a constant. Q charge on the ball is constant. Only theta can vary. So from here we can say that sigma is proportional to tan theta. So what are the options available to you as the answer? Let us see that. Options are sin theta, tan theta, cos theta and cot theta. Which one is the answer then? Tan theta, B. You already learned this question. Now question number 9. Two charges Q1 and Q2 are placed 30 centimeter apart as shown in the figure. A third charge Q3 is moved along the arc of a circle of radius 40 centimeter from C to D. The change in the potential energy of the system is, it is already given where K is. You have to find the value of K. Got it? Can you solve this? Yes, you can solve this question easily. So let us draw the diagram first.